Okay, yet another example of a kinematics problem. We're going to look at page 43, number 25 here. And this one's a little bit more challenging, but not too bad. It says a car traveling 45 kilometers per hour slows down at a constant 0.5 meters per second squared just by letting up on the gas. Calculate A, the distance the car coasts before it stops, B, the time it takes to stop, and C, the distance it travels during the first and fifth seconds. Okay, so the car was moving initially at 45 kilometers per hour, so that's my initial velocity. It slows down at a constant 0.5 meters per second squared, so the acceleration is 0.5 meters per second squared, but we're going to make it negative because it's slowing down and the initial velocity is positive. So the acceleration has to be negative. And the car is going to eventually come to rest. So VF is 0. And the question in part A is how far does it go before it stops? The second question is how long does it take to stop? And then the third question we'll get to in a little bit. I want to make sure we do the first two first. Okay, so there's our checklist. The problem is, though, that we have the velocity, original velocity, in kilometers per hour, and that's not the right SI unit. So we're going to convert this to meters per second before we do anything else. So what we're going to do is write 45 kilometers per hour. Okay, we're going to convert to meters per second. So we're going to multiply by 1,000 meters per kilometer. That'll get rid of my kilometers. And I'm going to multiply by 1 hour over 60 minutes. Hours will cancel, and times 1 minute over 60 seconds, and minutes will cancel. Multiply all the tops together, divide by all the bottoms multiplied together. You're going to end up with 12.5 meters per second. So instead of using the 45 kilometers per hour, forget about that now and use 12.5 meters per second instead as the initial velocity. Now the first question was what is the distance that the car will travel? Since we don't know the time, it makes sense to use this equation, the no time equation. But we need to isolate delta x here. Remember, delta x is one variable. So we're going to subtract VO squared from both sides. And then we'll divide by 2a. So now I have delta x equals VF squared minus VO squared over 2a. Okay, VF we know is 0. VO is 12.5 meters per second. Remember, you have to square that. Divided by 2 times the acceleration is negative 0.5 meters per second squared. Okay, so we're going to do divided by 1. You get 156.25 meters. That's how far it takes the car to stop. Second question is how long does it take to stop in time? Okay, so the easiest way to do that would be to use the VF equals VO plus AT equation and solve it for t. So if we subtract VO from both sides, divide by A, and now we have an expression. So VF is 0. VO, remember, is 12.5. The acceleration is negative 0.5 meters per second squared. So this is going to turn out to be 25 seconds. Remember, it's a time. Okay, and then it asks how far does it travel in the first second and in the fifth second. So it's kind of a two-part question. The first second's easy. We just use the delta x equation. And instead of plugging in this 25-second time, we're going to plug in a time of 1 second to see how far it goes in that second. So delta x equals 12.5 meters per second times 1 second plus a half negative 0.5 meters per second squared times the time is 1 second squared. Okay, so what we're going to end up with here is 12.25 meters when you plug it all into the calculator. So that's in the first second. To get the 5th second, they're not asking how far does it travel in 5 seconds. They're asking how far does it travel in the 5th second. So what you should do is, the same way we found how far it travels in the first second, you plug in to the delta x equation for 5 seconds, and you'll get some answer. And then do the same thing for 4 seconds and get some answer. Subtract those two answers, and you should get the answer for what it traveled between the 4th and the 5th second.